Is humid air more dense than dry air? Let's find out. Dry air, meaning zero humidity, is actually a mixture of several gases. Here are typical percentages by volume fraction and ppm: nitrogen, oxygen, argon, carbon dioxide, and other trace gases. We'll ignore those in our analysis since they're less than 20 ppm each. Humid air has all these components plus water vapor. The amount of water vapor depends on air temperature and relative humidity. So we ask the question, is humid air more dense than dry air? Well, it certainly feels more dense, dude. You're right about that, Joe, but let's do the analysis to find out. Here's an equation for the volume fraction of water vapor in air, where V water is the volume of water vapor, V total is the total volume, RH is the relative humidity, Psat is the saturation pressure or vapor pressure, and PATM is the atmospheric or total pressure. For example, at 25 degrees C, Psat is 3.169 kPa. We look this up in thermodynamic tables. So if the relative humidity is 50% and the air is at 100 kPa at 25 degrees C, the above equation gives a volume fraction of water as about 1.585%. But if the air temperature and pressure remain the same, when you add the water vapor, you have to displace all the other gases. So let's list the molecular weight of each component gas: nitrogen, oxygen, argon, carbon dioxide, and water. Notice how small the water one is compared to all the others. That's because it has 2 hydrogens and only 1 oxygen. So comparing at the same temperature and pressure, we're displacing heavier molecules with lighter ones. Thus, humid air is less dense than dry air. Dude, then why does it feel more dense, man? Well, it has to do with evaporation. In humid air, our skin can't cool us down as easily as with dry air. So the air feels more sticky or thick, but the density is actually lower. I did some calculations with our example case. For dry air, I got the total density to be about 1.26 kilogram per meter cubed. But for the humid air, the density dropped to about 1.25 kilogram per meter cubed. So for this example, the humid air is indeed less dense than the dry air, though not by much. In summary, dry air consists of several component gases. Humid air consists of those same component gases, but they're at smaller volume fractions because they're displaced by the water vapor, and water vapor molecules are much lighter than the other component gases. The result is that at the same temperature and pressure, the overall density of the air decreases as relative humidity increases. Humid air is less dense than dry air. Thank you for watching this video. Please subscribe to my YouTube channel for more videos. 1, 2, 3. That's all there is to it.